Hello, this is Nick of Time. Welcome to this, our 20th talk on the physics of time. The picture shows there's different ways to represent time, different views. We're going to talk about transforming the special relativity view into a physical view. And once again, my camera's still on the fritz, so we'll have a disembodied voice, but as we noted before, it's the content of the presentation, the ideas that are presented that counts in critical thinking. Okay, we're going to talk about how to replace special relativity with a physical theory. One way to think about it is converting special relativity to a physical theory. Special relativity, as we've seen, is a simulation where each inertial frame simulates being the single preferred frame. Sometimes the simulation will work, and often it will lead to contradictions and paradoxes, as is well known. Hence, we take special relativity's treatment of kinematics and reformulate as a preferred frame theory. For the kinematic equations, including time dilation, alleged time dilation, which we'll rename as clock retardation, we replace the construct of relative velocity with absolute velocity as measured from the preferred frame. This yields absolute kinetic energy and absolute momentum, and that replaces special relativity's constructs of relative kinetic energy and relative momentum. The result is we have absolute kinetic energy and absolute momentum that are physical properties of objects, not, as in special relativity, multi-valued or observer-dependent bookkeeping constructs. So that's a significant advance in a physical theory. Again, we talked about this a little bit before, but we have universal or standard time defined in terms of proper time, and the physics that relates proper time in the preferred frame to proper time for other observers. I initially wrote for other frames, but again, I'm trying to get rid of talking in terms of frames, but it is a very useful term and often replaces a long phrase. But here I replace for other frames with for other observers as part of this transition of getting away from being frame-oriented. This universal time, modeled on the GPS model, yields absolute simultaneity. And absolute simultaneity, in turn, yields this third bullet, where we get all of the missing physics missing from special relativity's view, and missing because of special relativity's construct of relative simultaneity. Let's look at the twin paradox as an example. In special relativity, the twin paradox can yield the net proper time difference for the total trip. But relativists, many of them, say we can't describe in special relativity how that net proper time accumulates because of relative simultaneity. In other words, different observers will have different views on how that proper time difference accumulates. But with absolute simultaneity, then we have all observers agreeing. So there's a definitive description of how the net proper time difference accumulates physically. And that's just one example. A lot of missing physics will now be explained in detail by this physical model alternative. Okay, what's the relationship of this physical replacement to Lorentz relativity? Well, the replacement is the ether-independent level of Lorentz ether theory, namely Lorentz relativity. Now, we don't want to scare off people who have a knee-jerk negative reaction to discussing ether, so let's go to the second bullet. The preferred frame is not necessarily the ether rest frame. For example, it could be some other construct like the rest frame of the local gravitational field. Now, neither pro-ether or against the ether, it's just that what I've looked at in terms of logic and in terms of the experimental data conclusively leads to the need for a preferred frame. But as of yet, I haven't seen the experimental data that shows it has to be the ether rest frame. And there's no evidence against it being the ether rest frame. So for the third bullet, we have our conclusion is motion with respect to a single physical entity causes physical effects. Okay, we want, when we're constructing a physical theory replacement of special relativity, frames are out, frames not. And we have to recognize that transformations are a math tool. They don't imply the physics of what's really happening. So we want to focus on physical entities rather than frames. Also note that inertial frames means no external forces acting on entities. When relativists argue, try and rebut the arguments against special relativity, they act as though they don't know this. Clearly they do know it, but they act as though they don't know this fundamental fact, and that causes a great distortion on their view of physics and causes them to miss the essence of some of the arguments against special relativity. Okay, once the physical theory of physical entities is developed, then one can add the mathematical transformation as a potentially useful tool. But we don't want to go vice versa. We don't want to start with transformations and then have the transformations being the driving force for developing the physical theory. Because then you end up with a theory that implies a physics theory that doesn't represent physical reality. It's a math modeling theory. Okay, we also want to avoid having action at a distance. We don't have direct action between distant frames or entities. But we can have external entities affect local entities, but only by affecting local conditions. No remote, no action at a distance, but external entities can via fields affect other local fields, as an example. Okay, let's look at the relativity principle. For example, the relativity of mechanics. That was in use for about 5 centuries. Fine, let's keep it. But remember, just because it gives the right numerical answer doesn't mean it gives an accurate physical model, as we've seen in special relativity. For example, we have the third bullet. Observer-dependent optics is perfectly good physics, but not an accurate description of what's happening physically. Let's think of the example of where we have two identical twins and they separate from each other. Well, each twin will observe the other twin as shrinking in size, but there's no physical shrinking in size. So as long as we remember that just because, say, a relativity principle leads us to the right numerical answers doesn't necessarily mean it's giving an accurate model of what's happening physically. We'll continue on this theme for the next slide. In particular, we need to drop the all frames are equal and indistinguishable paradigm, because frames are not important in physics. It's physical entities, physical objects, and physical fields. So, knowing the physical model, which often lies beneath the relativity principle and is obscured by the relativity principle, will provide better physics and additional benefits. Once we know what's going on physically, it will allow us to better manipulate the physical environment. Okay, what's next in this series? Well, there'll be 3 very short talks, around 5 minutes, each giving a quick QED argument on why special relativity's relativity must be replaced by physical absolutes. Thanks for joining us for this talk, and hope to see you next time. Those 3 short talks, again, very short, couple of minutes. Even if you don't agree with the QED argument, I think you'll agree that it's a thought-provoking topic, and if it's thought-provoking, it's worth your while. Hope to see you then.